Hey guys, welcome back. In the previous video, we completed the output port board right here. We already inserted it into the computer. And in this video, we'll be building the input card, I guess. These are called cards in SCELBI terms. And it's pretty basic, pretty simple as well as the output board. Output card, I guess. Keep on calling it boards. Yeah, we'll probably assemble this pretty quickly. There are a lot of resistors that need to be installed. In fact, I have all of them right here. I think there's like 64 of them. So it's going to be some time to assemble those resistors. The rest are a couple of capacitors, diode, fuse, and I think maybe like 10 ICs. Yeah, and so here's the description of the input card. This page here kind of describes it a little bit and has the assembly instructions. I will actually one thing I realized, there's a page here in between the assembly instructions, and that's the layout sheet. I actually took it out already, but this is the layout sheet for the card. Pretty straightforward. I took it out because I'll be using it. I'll be referencing that when we assemble the board. If we skip down to the I guess the last part of the manual, which has all the details about each card, schematics, and things like that. Here's the page for the input card. It tells you the power usage or power requirements, and also goes into details on how the input card works. Basically, it uses some multiplexing to accomplish its task. And it has the schematic. Yeah, just like with the other boards, I actually used the schematic to construct it or reconstruct it in KiCad, and then I created the PCB in KiCad as well using the schematic. So, and I cross-checked it against the original board, so I think it's pretty accurate. And the last page of this input card, is the parts list. Not that many parts, should be pretty basic. I have all the parts right here. In fact, as with the other cards, we'll be using these IC sockets instead of soldering the ICs directly on the board. Well, I guess we can go ahead and get started on the assembly. As I mentioned, I'll be referencing this layout sheet. And yeah, let's go ahead and get started. We'll start with the resistors as usual, and this is probably the most time-consuming part because there are 64 resistors and we have to bend them and insert them, solder them in, and then trim all the leads. And you know, I guess you could do it quickly, just bend it quickly and put it in. In my case, I kind of take my time and make sure that all the resistors align the same way and orient in the same direction. So it might take a little bit longer for me, but let's go ahead and get started. And by the way, there is only one value for all the resistors, so all 64 resistors are 10k ohm. And those are the resistors. Next, we'll install solder in the IC sockets. And if you really want to, you can go ahead and solder in the ICs directly into it. I know some people like doing that. It just makes it harder to fix issues with ICs or debug issues. For example, you're trying to debug this board, and sometimes it makes sense to remove some of the ICs to test something, and it just makes it harder when they're soldered in directly into the board. So the IC sockets, which might not always be like the original, do help with debugging and repairing. And by the way, you saw me using this blue tape here. I use it to keep the, this is the like painter's masking tape, but I use it to keep the components in while I flip it over. Someone actually recommended using a purple tape just like that. It's a purple masking tape, and I guess it's not as adhesive as the blue one. And if you're worried about removing these traces here with the tape, maybe the purple one might work a little bit better for you. But honestly, I haven't had issues with the traces being removed with the blue tape, so I will continue using that one in my case. Okay, so the IC sockets, I think there are a couple of 14 pins and a couple of 16 pins, and just to be safe, just to make sure we insert the correct one in the correct position, we'll insert the 16 pin sockets first. And then we can insert these fuse holders in. I'll insert the fuse into the holder first. And again, just want to make sure that we insert these fuse holders in the right orientation, which is actually why I insert the fuse before I insert them into the PCB, just so I don't make a mistake here. But one side of this fuse holder is the edge. Just want to make sure that the edge is on this side and this side when we insert it into the PCB. I guess we can insert this diode here. I forgot about it when I did the resistors. But let's see, where does it go? Oh, it goes right here actually. And I just realized I'm missing one of the resistors, so I guess I need to get one more 10k ohm resistor that goes right over here. But let me go ahead and insert this diode in. And it looks like the holes for the diode are just too small for the diode that I'm using, so I may need to drill it out. So I got the diode inserted here and soldered in, and also the missing resistor. Because I drilled out the hole here, I'm gonna just apply a little bit of solder on this side because there's a trace connecting to it. I just want to make sure that it's solid. Just a little bit, and there you go. I guess in future versions I'll try to make these holes a little bit larger for the larger diodes. Okay, now let's do this 10 microfarad capacitor. And I want to make sure that the plus is oriented correctly. I think the plus is where this burgundy color is, or the brown color is. And now these ceramic capacitors, there's just a couple of them here, so let's go ahead and insert them all in. And lastly, we can insert the ICs into the sockets. So we'll have to remove these little plates on the sockets themselves before we insert the ICs. Let me just go ahead and do that. And we'll reference this parts layout sheet for the location of each IC. And we're finished. Now is a good time to just examine the ICs that were inserted, making sure that none of the pins were bent inside and outside. And also that all the pins are there. So there were some ICs that I inserted in some motherboards in the previous videos that didn't have all the pins on the IC, so I had to solder a piece of lead to extend the pin. Also, we want to make sure that they're oriented in the right direction. It looks like all the ICs here are oriented up, and I think it looks pretty good. Okay, so I guess the last step is to, I guess we could run a test, and let's see what actually the manual says for verifying this board. Initial inspection and testing. Carefully inspect both sides of the board to make sure that there are no solder shorts, which I'm actually going to do off screen. Insert the 3/8 amp fuse into F1. It's an 8 AG type fuse, which I already did. And use an ohmmeter to make the following measurements between pin A1 and A3. That's one is ground, one is positive 5 volts. We want to make sure that the resistance there is greater than 5 ohms, because if it's less than 5 ohms, there's probably a short there. And yeah, that's pretty much it. I guess the final testing, we need to have it inserted into the SCELBI computer and basically have some items, something connected to the input port, and have some sort of software that verifies the data that's coming into the input ports. But I guess for now we're going to go ahead and insert it into its position here. It's going to be the 4th card from the front. Just like that. And I guess one last step is to plug it in and just verify that it still works. I mean, the computer, that is, and that we don't actually see any smoke coming out of the boards. I guess it'll be a literal smoke test. So let me plug it in and do that verification right now. I have the power supply sitting to my right over here. We actually built that power supply in a previous video, if you remember. Okay, I'm gonna power it on. Seeing the lights on the front panel, which is good. Okay, I'm not seeing any smoke, so that's a good sign. I'll have it run for just a little bit longer, and I'll kind of try the ICs to see if any of them get overly hot. But other than that, I think we are finished with testing. I'm going to go ahead and turn it off because it seems pretty good. Just a reminder that I'll have these PCB sets, empty boards, available at www.callenshop.com that you can purchase and make your own SCELBI computer. I believe it's a set of 8 boards. And I'll also make the gerbers available if anybody wants to get them manufactured or fabricated themselves. It might be a little bit more expensive, but those will be available eventually. And I think that's it for this video. I believe the next board, or I guess the next video, will be for the memory expansion board, and then we'll also make a memory or a RAM board, and maybe a ROM board, which is coming up in a future video. Don't forget to like if you enjoyed watching this video, and also subscribe so you don't miss any of the upcoming SCELBI videos. We'll also have some additional videos coming up for a different computer. Actually, some of them are not even computers, but some vintage electronics that were available at one point. So don't forget to subscribe so you don't miss that. Thank you for watching, and I'll see you in the next video.